This question is taken from the June 2022 paper 52 from the Cambridge CIE specification. It's a normal distribution question. So the first thing I'm going to do is draw a quick sketch to picture what is being asked of us. So our normal distribution bell curve, we are asked to find the probability between 1.98 and 2.03. In the question, we are told that the mean is 2.02. So that's the sort of middle point of our bell curve. So 1.98 is going to be to the left and 2.03 is going to be to the right. So we're trying to find the probability of this section in our bell curve. Now, to use the tables in our formula booklet, we're going to need to standardise this. So to standardise this, we're going to use the formula Z is equal to X minus mu over our standard deviation. Now from the question, we're given that mu is equal to 2.02. X is the X value we're trying to do. So for the first one, it's 1.98. And then in our question, we're given the standard deviation squared. We're given the variance. So 0.03 is our standard deviation. So I'm going to do this for 1.98 and for 2.03. Now this simplifies to the probability of minus 1.333 is less than Z, which is less than 0.333. This is what we're going to use for our tables. Now, to find the probability trapped between these two values, we're going to find the probability that Z is less than 0.33. And we're going to subtract the probability that Z is less than minus 1.333. So let's start with the first one. Z is less than 0.33. We're going to find this on our tables. So we go to 0.3 and then we've got another 3. So that gives us 0.6293. And then we've got another 3. So I'm going to go to the 3 column and that tells us we need to add 11 onto the 0.6293. So this gives us a value of 0.6304. Now the second one is a little bit harder because we're going less than a negative and our table doesn't have a negative. So we're actually going to use symmetry. We're going to find 1.333 in the table and then subtract that from 1 because that's our symmetry. So on the table, that gives us a 0.9087. Now, if I just type this into my calculator, this is going to give me a probability of 0.539.